Okay, so on Friday, we went through acidic redox reactions. Okay, so we know that we have acids and bases. So on Friday, we went through the acidic reactions. Today, we're going to go through basic reactions. So, basic solutions. Have a high concentration of hydroxide ions. Which is OH. Okay. All right, so we're going to look at one example. So we have a basic solution containing sodium sulfite and we're going to mix that with potassium permanganate. Okay, so let me give you the formula for that. It is MnO4 minus SO3 minus 2 manganese and oxygen, and then SO4 minus 2 aqueous. Okay, so there's our reaction, and I'll let you guys catch up for those of you that are taking notes still. Okay. So as of right now, we're not doing anything new. So what are we going to match up, Evelyn? So let me make this easy for you. Let me just throw some numbers up here. 1, 2, 3, 4. For the two half reactions, what's going to go together? Just give me the numbers if that makes it easier. 1 and 2 are going to go together. So remember, you want to pick things that have the same species in them. 1 and 3, yeah. So this one has manganese in it. This one has manganese in it. This one has sulfur in it, and this one has sulfur in it right here. Okay. Now, I did ask the question because we were looking at this on Friday, and I had a brain fart, and I was like, well, isn't one of them supposed to be oxidizing and reducing? They are, but it comes up later in the reaction when we have the electrons, when we actually have to throw the electrons in. That's where we end up seeing oxidizing and reducing. It's not obvious at the beginning. Okay, so we have two half reactions. So I'm going to take the first one. So we've got MnO4 minus, and then we have MnO2. Okay. Manganese is already balanced. So I've got one manganese on the left, I have one manganese on the right. Okay? David, what's our next step?
I just did this. I forgot.
Look at your notes. Do you have them? What's our step after we make sure that?
Assign oxidation numbers.
Nope. Before after that.
Okay.
So manganese is balanced. What else is in this equation?
Balance of the oxygen.
Oxygen. Balance the oxygen with H2O. So I'm going to add H2O over here. How many do I need to balance? 2. Because I have 4 oxygens on the left, I have 2 on the right. I need 2 more oxygens, so I'm going to add 2 H2Os here. Okay? Great. So now what do I do? Krista, what's my next step? So look at the reaction. You've got manganese on both sides. You have oxygens on both sides. There's one thing that doesn't exist on both sides, Krista, yet. What is that? Look at all the elements that you have. No, so individually. So you've got manganese, you have oxygen, and you have hydrogen. What isn't on the left side that is on the right side? Hydrogen. So look, you've got manganese on both sides, you've got oxygen on both sides, okay? We don't have hydrogen on this side. You're looking at the whole molecule. Just look at the individual pieces. So we balance the hydrogens by adding H plus on both sides. Okay? How many hydrogens do I need to balance with the right side? 4. Okay? Now, this is where we need to go through and we need to figure out how many what our total charge is. So 4 and positive 1, 4 times positive 1 is plus 4. So this one is plus 4. This right here is minus 1. So the total charge on this side is going to be plus 3. On the right side, this one is 0. This one is 0. There's no charge on either of those. So the total charge on the right side would be 0. Looks like a donut. Okay, so I've got plus 3 on the left. I have 0 on the right. And remember, electrons are a minus 1. I want the two sides to match. So what do I need to... How many electrons do I need to put, and which side do they need to go on, Angeli?
Left side, 3.
And 3. Good. So we're going to add 3 electrons here. Okay. Good. So that one's done. So now let's do the second half reaction. So the second half reaction deals with sulfur. So we have SO3 minus 2, and then we have SO4 minus 2. Okay. So sulfur's already balanced. So Cassie, what do I need to do next? Add an H2O on the left side. So I have 4 on the right, I have 3 on the left, so Cassie says add 1 more H2O on the left side so that I have 4 oxygens on the left. Okay, good. Okay, after H2O, Ashley, what do I need to do?
You add the hydrogen,
Okay, which side and how many?
the left and 2.
So we already have 2 on the left with the other side. So we're going to add 2 hydrogens on the right side. And it's great. My pen stopped working. Okay. Well, this is great. Candy stopped working. Let me try refreshing this. Okay, there we go. So add 2 hydrogens on the right side. All right. Now we need to do our charges. So we've got 0 here. We have minus 2 here. So the total on the left side would be minus 2. On the right side, we have minus 2. And then we have 2 times positive 1 is plus 2. So this would be, this would be 0. did it do that? Wow, Cammy does not want to cooperate today. Look at that. Let's try this again. Okay, so the total over here would be 0. Okay, so how many electrons do I need? And which side do they need to go on? Paola?
2 on the left.
On the left? I agree 2, but which? Check your side. So you have -2 here, you have 0. Remember the electrons are -1 each. So we can't raise the 2 up, but we could bring the 0 down. So we'll go on the right side. Okay, just to make this a little clearer, I'm going to erase all this extra stuff on my scratch work here. Okay, so we have our 2 reactions now. What's our next step, Joel? We got to get something to cancel. What do we need to do?
Oh, no. The electrons.
Okay, so our electrons need to cancel. Okay, so we've got 3 here and we have 2 here. So I can't just multiply one of our reactions. I have to multiply both of them to get a least common multiple. So between 2 and 3, what's our least common multiple? 6. Okay, so for the top one, I'm going to multiply it by 2 to get 6 electrons. And the bottom one, I'm going to multiply by 3 to get 6 electrons. Okay, so let's go ahead and do that. So let's see, that'll be 6 electrons plus 8 hydrogens plus 2 MnO4 minus 2 MnO2 and then 4 H2Os. Is that right? That looks right. Okay, the second one, multiply everything by 3. So we'll have 3 H2Os. 3 SO3 minus 2. Okay. I think that's right. Okay. So, at this point, Nikki, what do we need to do?
Cross off stuff that's on both sides.
Cross off stuff that's on both sides. Okay, so like our electrons should cancel. If you don't cancel the electrons, you made a mistake. They should be the same number on both sides. Okay. What are some other things that we can cancel out here? Go back here. What are some other things that we can cancel out here, Joel?
Oh, like the hydrogen and the H.
Oh, oh, look at you going for a double. That's okay.
Oh.
That's okay. All right, so hydrogen, right? So I can get rid of all 6 here, and I can get rid of 6 of the 8. So instead of having 8, I'm going to have 2. And then you said H2O. So all of my H2Os over here go away, and I will only have 1 H2O over here. Everything else is different. So now we add them all up. So let's see, we'll have the 2 manganese oxide. We'll have 3 SO3 minus 2. We'll have 1 H plus. Oh, no, sorry, 2 H plus. Okay, I'll let you guys catch up there for a second. I know that's a lot to write down. Okay, everybody's got it. All right. So here's the only difference between basic and acidic redox reactions. So for basic reactions, this is only for basic reactions. The number of hydrogens that you have, you're going to cancel out by adding OH to both sides. You're going to add the number, so I need actually 2 OHs here. Okay, now, I want to look at these two pieces right here. So you have 2 OHs and you have 2 hydrogens. We're going to combine those so they end up being water. We're going to combine those so they end up being water. Okay? So you will have, we'll rewrite this. You'll have 2 waters. Okay, I'll pause for a second, let you guys catch up. Okay, so I combined the H plus and the 2OH, so I now have 2 waters there. Okay, and then there's now water on both sides, so I can get rid of the water on the right side, and I can get rid of 1 of the H2Os here. So my final balanced basic redox reaction will be this. Okay, so I know that was a lot, but the steps up until the very end are the same as the acidic solutions. Okay, and you don't necessarily need to remember, like, okay, step number 3 is oxygen, step number 4 is hydrogen. I think it's easier if you just look at the elements that are there and figure out, okay, well, this side has elements A, B, C, the right side only has B, C, so I need to add the other one in. Okay, I think it's easier to think about it that way rather than trying to memorize the steps, but if you prefer, you can memorize the steps. So the last step is adding OH to cancel out the H pluses to both sides, because H plus we associate with acids, OH we associate with bases. Okay, and then you have to cancel out the waters. Okay, now that was a lot. What questions does everybody have on this?
Why did that become water?
That's a good question. Okay, so the question was, why did that become water? So total, let me add another page. So you have an OH, and then you have an H. We have 2 of these, right? So when I add them together, it becomes, we now have 2 hydrogens and 1 oxygen. This is OH minus, this is plus. So opposites attract. Do you see? Okay, yeah. So you've got OH and then you have H and you just add them together. So there were 2 of them. So that's how we had 2 waters right there. Okay, other questions on that one? Okay.